Find inverse z transform of z into z plus 1 divided by z minus 1 whole cube using Cauchy's residue theorem. Let x of z is equal to z into z plus 1 divided by z minus 1 whole cube. So x of z power n minus 1, which is equal to z into z plus 1 divided by z minus 1 whole cube into z power n minus 1. Both sides you have to multiply z power n minus 1, which is equal to z power n into z plus 1 divided by z minus 1 whole cube. So z is equal to 1 is a pole of order 3, because z is equal to 1 if you are taking, it will become 0. So that's why z is equal to 1 we have taken, is a pole of order 3. So therefore we have to find residues. The residues formula is residues at z is equal to 1 is x of z into z power n minus 1, which is equal to limit z tends to 1, because it is a pole of order 1, that's why 1 divided by m minus 1. M minus 1 is 3 minus 1, 2 factorial. 1 divided by m minus 1 factorial, d power m minus 1 divided by dz power m minus 1. Formula is, so d square 3 minus 1 dz square z minus 1 whole cube z minus 1 whole cube into x of z, that is z power n into z plus 1 divided by z minus 1 whole cube, z minus 1 whole cube. So z minus 1 cancel. So therefore in the next step you can write as, which is equal to, so residues at z is equal to 1, x of z power n minus 1, which is equal to 1 by limit z tends to 1, 1 by 2 factorial will be 1 by 2, d square divided by dz square z power n into z plus 1, z minus 1 whole cube divided by z minus 1 whole cube cancelled. So which is equal to limit z tends to 1, 1 by 2. One time you have to differentiate with respect to z. So z power 1 you have to keep as a constant, you have to differentiate z plus 1. If you are differentiating z plus 1, you will get z is 1, 1 if you are differentiating 0, plus z plus 1 keeping as a constant, you have to differentiate z power n, that is n into z power n minus 1, right? N into z power n minus 1. So therefore which is equal to limit z tends to 1, 1 by 2 d by dz of z power n plus n into z plus 1 z power n minus 1. So which is equal to limit z tends to 1, 1 by 2. Again you have to differentiate with respect to z. So z power n, if you are differentiating n into z power n minus 1 plus n into z plus 1 you have to keep as a constant, you have to differentiate z power n minus 1. If you are differentiating z power n minus 1, you will get n minus 1 into z power n minus 2 plus n into z power n minus 1. Z plus 1 you have to differentiate 1 plus 0. So which is equal to limit z tends to 1, 1 by 2, z tends to 1, 1 by 2. So this will be, so directly also you can substitute for z tends to 1. So n z power n minus 1 plus n into n minus 1 into z plus 1 z power n minus 2 plus n z power n minus 1. We have simplified. So now which is equal to 1 by 2. For z you have to apply 1. So n into 1 power n minus 1 plus n into n minus 1, 1 plus 1, 2, 1 power n minus 2 plus n into 1 power n minus 1, which is equal to 1 by 2. So n plus 2n square minus 2n, right? So n 2n square minus 2n plus n, so which is equal to 1 by 2 2n square, which is equal to n square, which is equal to n square. So therefore x of n, which is equal to sum of the residues, which is equal to n square. This is the final answer.